Hi everyone. In this video, we are going to learn how to make a decision in a hypothesis test. We'll introduce an important idea called the p-value, learn how it helps us make a decision, and then learn how to write the final conclusion. One important note before we begin. In this lesson, we'll assume that the p-value has already been provided. Don't worry about how to calculate it yet. That's what we'll learn in the next section. Today, our goal is simply to understand what the p-value tells us and how to use it. Let's get started. Let's begin with the idea of statistical significance. A result is statistically significant if it is unlikely to occur when the null hypothesis is true. Another way to think about this is with the idea of a rare event. A rare event is an event with a probability less than 5%. Here's the key idea. When we perform a hypothesis test, we begin by assuming that the null hypothesis is true. Then we collect sample data. Now, suppose the sample produces a result that would be very unusual if the null hypothesis were actually true. If something very unusual happens, we begin to question our original assumption. That doesn't automatically prove the null hypothesis is false, but it does give us evidence against it. That's the basic idea behind hypothesis testing. We are looking for evidence that the null hypothesis may not be correct. So how do we measure how unusual our sample result is? That's where the p-value comes in. The p-value is the probability of obtaining the sample result, or even more extreme, assuming the null hypothesis is true. That's the formal definition. Here's a simpler way to think about it. Imagine that the null hypothesis is true. Now ask yourself, how surprising is my sample result? The p-value answers that question. If the p-value is small, then the sample result is very surprising. If the p-value is large, then the sample result is not very surprising. Notice that today we are only learning what the p-value means. In the next section, we'll learn how to actually calculate it. For now, just remember this idea. A small p-value means stronger evidence against the null hypothesis. A large p-value means there's not much evidence against the null hypothesis. Now, let's see how we use the p-value to make a decision. We are going to compare two numbers, the p-value and the significance level alpha. Remember that alpha is the significance level you choose before collecting the data. Most of the time, you see alpha equals to 0.05, although other values are possible. There are only two possible decisions. If p-value is less than alpha, we reject the null hypothesis. If the p-value is greater than or equal to alpha, we do not reject the null hypothesis. That's the entire decision rule. Here's an easy way to remember it. Small p-value implies reject H0. Since a small p-value means the sample result is unusual, it provides stronger evidence against the null hypothesis. Now, here's something that often confuses students. Notice that we said, do not reject the null hypothesis. We do not say accept the null hypothesis. Why not? Because failing to find enough evidence against the null hypothesis does not prove that it's true. It simply means that we don't have enough evidence to reject it. That is a very common mistake, so be careful with your wording. After you've made your decision, there's one final step. You need to write your conclusion using the context of the problem. The wording of your conclusion depends on whether the claim in the problem is represented by the null hypothesis or the alternative hypothesis. Let's look at our 4 possible situations. If the claim in the problem is represented by the alternative hypothesis and you reject the null hypothesis, then you would write, there is sufficient evidence to support the original claim. If the claim in the problem is represented by the alternative hypothesis and you do not reject HO, then you would write, there's not sufficient evidence to support the original claim. Now, suppose the claim in the problem is represented by the null hypothesis. If you reject the null hypothesis, then you would write, there is sufficient evidence to reject the original claim. Finally, if the claim in the problem is represented by the null hypothesis and you do not reject the null hypothesis, then you would write, there is not sufficient evidence to reject the original claim. One important tip. When you write your conclusion, don't just use the words original claim. Instead, replace that phrase with the actual claim or question from the problem's context. Your conclusion should sound like a complete sentence that answers the problem, not like a template. For example, instead of writing, there is sufficient evidence to support the original claim, you might write, there is sufficient evidence to support the claim that the average number of hours students study each week is more than 12 hours. Your conclusion should always answer the question being asked in the problem. To help organize every hypothesis testing problem, we'll use the same 6 steps process throughout this chapter. Here are the 6 steps. Step 1. Identifying the null and alternative hypotheses. Step 2. Identifying the significance level alpha. Step 3. Find the p-value. Step 4. Compare the p-value with alpha. Step 5. Make your decision. And step 6. Write the conclusion using the problem's context. You will use these 6 steps every time you perform a hypothesis test.